Hi, my name is Jake Emerson, and my research is on detecting complex events with networks of simple sensors. I'm co-advised by Professors Kate Beard and Mike Warboys. Complex aerial events such as hurricanes, traffic jams, and pandemics are simple for people to understand. However, these events are complex combinations of many factors. This research looks at how we can form a useful picture of these sorts of geographically dispersed events based only on data from simple sensor devices embedded in the environment. This research models the behavior of devices with both measurement and communication capabilities called sensor agents, which detect changes at points in space. Analyzing data from networks of sensor agents is like looking at the world through a cheese grater. As a red object moves behind the cheese grater, it's easy to interpret that thing to be an apple. Each agent or hole in the grater sees very little. However, these smaller bits of information, together with preconceived notions of what might be going on, form a bigger picture out of limited data. This leads to the question of how much and what kind of information do fixed and mobile sensor agents need to collectively detect an event that no one agent is able to detect by itself. In this research, we're developing a model of complex events which allows each sensor agent to share information with its neighbors, and in turn to build a wider view in its own memory. This research will investigate fusion of data to develop a broad perspective based only on shared local information, metrics for testing the similarity of event images from different sensor sets against one another. For example, test the identity of events in time step 2 against those in time 1, and see if they're the same or different. Simulation of the detection capabilities of sensor networks as spatial characteristics change, for example, by varying sensor density, clustering, or motion of sensor agents. By defining the salient concepts of aerial events, this model presents a standardized method for domain practitioners to explicitly specify event types based on their experience. Using these event specifications, sensor networks will gather information about events as simple data sequences, and the event framework will allow automated processes to monitor for occurrences over a wide area. For example, as vehicle spacing decreases, as measured by proximity sensors in cars, conditions become icy and vehicles begin to slow, as measured by sensors in and along the road. These sensor agents would collectively infer the presence of a traffic jam. And then approaching drivers with sensor agents in their own vehicles could use this information to choose alternate routes.